Hi, I am back again from MySlate, and in this video we will move on. If you remember, we were discussing the applications of derivatives in the previous video, and we looked at the rate of change of quantities. So here we will move further and discuss another kind of applications of derivatives, which is how to find this curve y equals x cube plus 2x plus 6, and we are also given that the normals, there could be more than one normal. That's possible. Because we might have 2 points on the curve of the equation that we are probably looking at, which might be the case here. So here it's given that the normals are parallel to the this straight line, right? So it's possible that there might be more than one normals parallel to this straight line, or there may not be any normal, right? Because you may have some complicated shape of the curve. So we'll not draw the figure here, but we'll follow the similar procedures. So we already given that the slope of the normals are the same as the slope of this line, and that slope is minus 1 by 14. How did we get that? Well, you probably already know that in the equation of the straight line, the slope is nothing but the negative of the coefficient of the x variable divided by the coefficient of the y variable. And if you are still not convinced, all that you need to do is, in this equation, you take derivatives of both the sides and you try to calculate dy by dx, right? If you do that, you would get pretty quickly this slope of this line. So the normals have the same slope that's given to us, and and we know that the slope of the normal is minus 1 by slope of the tangent. So we will also derive the slope of the normal from this equation of the curve. So for that, first let us get the slope of the tangent at a generic point xy, and that's dy by dx. So we basically calculate dy by dx, the expression for dy by dx. So that's pretty straightforward again, and we know that the slope of the normal at a point xy would be minus 1 divided by the slope of the tangent. So we have got the mathematical expression for that, which is minus 1 by 3x squared plus 2, and we equate that to the slope of the normal that we know already. And by solving this equation, we get two possible values of x. So you see here that there are 2 points on this curve where we have normals with this particular slope 1 by 14. So x could be plus and minus 2, and corresponding to those two values of x, we substitute them back into the equation of this curve to get two possible values of y, which comes to 18 and minus 6. So therefore we are talking of these 2 points on this curve, 2, 18 and minus 2, minus 6, where the normals on the curve have the same slope, which is minus 1 by 14. Okay, and now the remaining task is pretty straightforward, that at each of these points whose coordinates we know and the slope of the normal we know, we need to find the equation of the normal, and for each of those points we plug those pieces of information in the straight line equation to get two equations for the normal, right? Please remember here that although these two normals have the same slope given here by minus 1 by 14, but the equations are not the same, because those two normals don't represent the same straight line. They are different straight lines, parallel lines because they have the same slope, but distinct lines, and they cut this curve at two different points, which are given by these two coordinates. Okay, so I hope you have understood this simple application of derivatives to find the equations of tangents and normals on a given curve at a given point, and I'll now see you in the next video. Okay, goodbye.